Necessity is the mother of invention. Okay, we have heard this sentence a lot of times from our childhood. Now we will understand the actual benefit by understanding the difference between traditional and machine learning. Okay, the difference between traditional AI and machine learning, right? So in this video, you'll be provided with a very practical and clear guide how to understand the difference between a rule-based traditional AI versus a learning algorithm-based machine learning, right? And how the ill effects or the shortcomings of traditional AI led to the birth of machine learning, right? So first of all, we'll understand what is traditional AI. Okay, so traditional AI basically it works on rules written by human programmers. Okay, the rules which the AI system or the machine should obey in order to get a particular outcome. Okay, you can think of some recipe, okay, which is very carefully written out, a system that can do exactly what it has been told to do. No improvement, no adaptation, and no learning from experience, right? And that was traditional AI, right? Where there were rules written by humans, okay? No learning happened, okay? Because the machine need to obey by the rules, right? And it was, if you have done some amount of programming, you can relate with if-else logic, right? Pure conditional statements were written. Now, if we give real life example of this traditional AI, you can think of a traffic signal system, right? So if you have red signal, we need to stop. Okay. If in the signal the color is yellow, we need to slow down. And if in the signal the color is green, we need to go. Okay, we can like start moving our vehicles, right? So these are the three conditions. Now this will work, okay, in normal situation this will work perfectly fine, no issues. But what if the signal is green and there is a pedestrian walking by? Okay, some pedestrian is walking by the zebra crossing, what will happen? Okay, if you follow blindly those rules, what will happen? An accident will happen, right? And it will like maybe impact a human life. So that is the same, you can say the negative points which traditional AI had, because they were not learning in the process, that led to the birth of machine learning, right? So if we talk about traditional AI in software testing, okay, in a web page, what do we have? We have username, we have password, and we have this login button. We'll provide the username from the list of usernames we have. We'll provide the password from the list of passwords we have. And what we'll do, we'll go and click on the login button, right? So this is like, you can break it down into three steps. Like if username is empty, show error. Okay, you can write all these conditions. If password is empty, show error. If both are valid, then allow login. Okay, so this is again a rule based system. But what if something happens beyond all the rules you have written? Okay, where the traditional AI needs to adapt, right? Now we will see machine learning, okay, where the machine learns from data. Okay, instead of explicit if else scenarios, the machine learning discovers patterns in the examples itself, right? No manual rules are there. Okay, the machine decides on the rule. Okay, it decides on the pattern by itself. Okay, and thereby like it will try to solve your problem with the help of those patterns. Okay, and what if new pattern arises? Okay, what in case of new situation, because it is able to perceive, because it is able to figure out patterns by itself, it will adapt to the situation very promptly, very easily, okay, very swiftly, so that we can like avoid accidents like that happened in the traffic signal, right? And in let's suppose we take email spam detection as example, and we will like differentiate what happens in case of traditional AI and what happens in case of machine learning, right? The both approaches we will discuss, right? In traditional approach, what happens, we will write, okay, in spam detection, if something called free money is there in the text, mark it as spam. Okay, if the email contains click here, mark it as spam. Okay, if the whatever we have written, it has grammatical error, syntactical error, or some kind of error is there, then mark it as spam. Okay, so it will be a fixed set of things which we can do for like detecting a spam email. Now, when we come to machine learning, what we'll do, we will provide the machine with data. We'll provide 10,000 spam email examples. Okay. And also at the same time, we'll provide 10,000 legitimate email example also. So that the machine learning algorithm or the model, it distinguishes between a good email, okay, a legitimate email, or like a email from proper source versus a spam email, right? So with all those examples, it will get trained and it will try to recognize an email letter, predict whether an email is spam or not, right? The algorithm learns pattern, okay, based on n number of patterns it will try to decide, okay, whether an email is spam or not. And these rules, whatever we discussed, it emerges automatically. What we have done, we have provided data with label. Okay, it is example based on supervised learning. We are providing labels as well, that these are spam emails, these are legitimate emails. Now it is the machine who is trying to figure out, okay, whether it is a good email or a email from spam source, right? And now we'll try to give a human analogy. Okay, in traditional AI, what happens, a teacher will give you exact answers. It will give you 100 questions and 100 answer, okay, which is going to come in your exam. Okay, it will have all the step by step instruction how we need to write, so that no marks are being deducted. Okay, so that there is no room for interpretation also. We don't need to think anything. We like that will work only for certain scenarios. Let's suppose whatever important question the teacher is providing in the exam, you are getting only those questions. What if some of the question by mistake has been set by a different teacher, which is from the syllabus for sure, but not out of the list which is provided by the helpful teacher, right? Their traditional AI will fail, right? Now, in case of machine learning, the analogy will be a student who practices many problems, okay, who understand the syllabus very well, okay, who learns pattern by him or herself, right? So it will adapt to new situation. When that particular student is being asked any question, it will answer based on the knowledge, based on the patterns it has recognized, okay, and based of n number of things. No matter you are giving question from 10, a list of 10 important question, or a different 10 important question, it will answer no matter what. If something is from the syllabus, that particular student called machine learning will be able to solve, right? And by if we try to compare traditional versus machine learning quickly, in traditional we have rules written by humans. Machine learning, we have rules learned from data, okay. In traditional we have fixed behavior over time, but in machine learning we have improvement, okay. Traditional AI is very hard to update or modify, because what will happen, let's suppose it is a very complex scenario. Okay, we started with a very simple scenario, now the complexity has risen over time. So what will happen, what will you do? In traditional AI, you need to write 1,000 and maybe 10,000, 1 million rules, and which is not humanly possible. But in case of machine learning, because the model is able to recognize the pattern by itself, it is trying to train with the help of example. Let's suppose we need to adapt few more examples, we can retrain the model. It is very much possible, and we don't need to write it from ourselves. All the rules will be written by the model itself, right? And traditional AI breaks in those unexpected scenarios, okay, but machine learning adapts in the new patterns as well, okay. It has a very transparent logic, okay, but in machine learning we have black boxes. We are not sure in super edge case scenarios or very very critical scenarios what will happen, we are not sure. Even if normal scenario, we are not sure whether the machine is, but we have, we are close to the accuracy. It is never 100%, but most of the times we are close to 100% accuracy, right? And the spam filter we have already understood. Now with a better approach, we'll try to understand. Let's suppose in traditional AI we are writing, if an email contains free, okay, spam it, okay. If email contains offer, spam it. But what will happen, there are some critical problems, okay. The spam words appear constantly, new words appear constantly every time, okay. Spammers also use creative misspellings, okay, like instead of free, they will write FR3E, which is very much like to the human eye. If you don't, you are not studying the email carefully, you will think that it is free. Okay. And free shipping is a legitimate like group of words, but free, you can buy something for free, is again like it is something leading to a spam, right? So too many rules are there, okay, too many failures are there in case of edge case, and the maintenance is very difficult, right? And this led to the birth of machine learning, right? Because there were so many failures, and with each and every change in data, we need to write new rules of our own, and it was difficult to maintain as well. The machine learning was born where the data or the model figure out its own decisions, okay, its own rules based on the data. And this was the video, guys. Okay, if you feel that your understanding has improved with the 10 minutes you have spent on this video, please press the like button. Okay, please subscribe to Akansha Academy for more such videos, because we'll be again like we'll coming back with more such videos. Thank you so much.